Welcome to Tech Explained. Today we are covering Edge AI.
A really fascinating area.
It is. We're seeing this explosion of data, aren't we? Coming from all sorts of interconnected devices.
Absolutely. Everything seems to have a sensor these days.
And that's really driven the need for something different, this thing called edge computing.
Right. Because sending all that data back to some massive centralized data center, it's not always practical.
Exactly. Edge computing is about processing that data much closer to where it's actually generated, right there at the source.
Yeah, think about the sheer volume. Smartwatches, industrial sensors, cameras, it's immense.
And all that data holds incredible potential, but like you said, sending it all to the cloud constantly, it creates issues.
Definitely. There are delays, what we call latency. It's like that lag you sometimes get streaming video, but imagine that impacting, say, a factory robot.
Not ideal.
Not at all. And it eats up a lot of network bandwidth, too. For many modern applications, especially ones needing instant reactions, that old centralized model just doesn't cut it anymore.
So edge computing brings the processing power closer.
Precisely. Right where it's needed most.
And then, layered on top of that, we have the incredible progress in artificial intelligence, AI, letting machines learn, spot patterns, make decisions, mimicking human intelligence in some way.
A powerful tool in its own right.
And when you put those two together, when you actually deploy those AI algorithms, those machine learning models, directly onto the edge devices themselves.
That's Edge AI. You've got it. It's about embedding that intelligence right where the data is born, often tailored for very specific uses in different industries.
It feels like while edge computing on its own and AI on its own are pretty well established now.
Yeah, widely adopted.
This specific combination, edge AI customized for different sectors, that feels like a really dynamic, still emerging field, less saturated maybe.
I'd agree. There's a lot of untapped potential there compared to, say, standard cloud AI.
And what's really interesting, I think, is how many different fields it touches.
Oh, absolutely. It's inherently multidisciplinary. You can't just be a cloud software person. You need to understand the actual hardware, the embedded systems running at the edge.
Right, the nuts and bolts.
And obviously, you need a strong grasp of AI and machine learning itself, how to build and refine those intelligent models.
Makes sense.
But maybe the most crucial piece, arguably, is understanding the specific industry. The details of manufacturing or healthcare regulations or the demands of the energy grid. That domain knowledge is key.
And bringing all that together, that sounds like a recipe for a skills gap.
It certainly creates one. But on the flip side, for people who can bridge those gaps, embedded systems, AI, industry knowledge, there are huge opportunities opening up.
Okay, so let's dive a little deeper then. What exactly is Edge AI, fundamentally?
At its heart, Edge AI is the, let's say, strategic decision to run AI algorithms and machine learning models directly on local edge devices.
And these devices, they cover a wide range.
A very wide range. It could be simple sensors collecting temperature or motion. It could be sophisticated IoT devices managing machinery. Our smartphones are edge devices, really.
Okay.
You also have specialized embedded systems, like in cars or even local on-site servers within a factory or building. The key is they're positioned close to the data source.
So the idea is, instead of constantly talking back to the cloud, these devices can process and analyze data right then and there.
Precisely. That ability for local real-time processing and analysis is the defining feature. It dramatically reduces or sometimes even eliminates the need for constant cloud interaction.
You hear the term AI at the edge sometimes too, same thing.
Yeah, exactly. It's used synonymously. The core idea is giving these edge devices intelligence, allowing them to analyze data and make decisions autonomously with minimal help from a central system.
It sounds much more efficient, more autonomous.
It is. You can think of it as a distributed intelligence model. Instead of one big brain in the cloud, the intelligence is spread out across the network of devices.
Which have advantages.
Big advantages. Especially for applications where speed is critical, data security is paramount, or you just absolutely need reliability.
Okay, I think I'm getting a clearer picture.
Yeah.
So what are the main benefits driving this push towards edge AI?
Well, the first big one, and we touched on it, is cutting down latency. Processing locally bypasses the round trip to the cloud and back.
Right, no transition delay.
Exactly. And that's absolutely vital for things like autonomous vehicles making split-second safety decisions, or industrial automation needing immediate control, or even real-time medical diagnostics where milliseconds matter.
So near instantaneous reaction times.
Pretty much, moving from potential internet lag speeds down to something closer to human reflex speeds for those critical tasks.
That's a huge difference. What else?
Another major benefit is minimizing internet usage, and therefore, bandwidth consumption.
Oh, okay.
If you process data locally, maybe you only need to send back the important findings or summaries, not the raw fire hose of data.
Right, just the key insights.
Which leads to significant cost savings, especially if you have thousands of devices or you're operating somewhere with flaky or expensive internet. It's like sending the final report instead of every single data point you collected.
Fewer cloud trips mean lower bills. I see the economic logic there. What about privacy and security? That seems important too.
Hugely important, and a major driver, especially in regulated industries. When sensitive data stays on the local device for processing,
It's less exposed.
exactly, the risk of interception during transit to the cloud is significantly reduced. Think healthcare data under IPA or financial transactions. Keeping it local shrinks the attack surface during transmission.
Makes sense. Local processing means fewer opportunities for data breaches in transit.
Precisely. And related to the cost point earlier, it's not just about bandwidth savings. Shifting processing to the edge can also reduce your reliance on expensive cloud storage and compute resources. The edge devices do more of the heavy lifting.
So distributing the workload can make the whole system more economical. Okay. What happens if the internet connection goes down?
That's where enhanced autonomy and reliability really shine. Because the intelligence is on the device.
It can keep working.
Yes, it can continue processing data and making decisions locally, even if the internet is patchy or completely unavailable. This is crucial for remote industrial sites, farms far from good connections, or during emergencies when networks might be down.
The intelligence keeps running, network or not. That's a massive advantage in those scenarios.
Absolutely. And another benefit flowing from that local processing is real-time analytics and getting immediate insights.
Faster results.
Much faster. Because the analysis happens right at the source, you can spot trends, anomalies, or actionable information almost instantly. This leads to quicker decisions and responses. Think of a security camera with edge AI spotting a problem now, not after sending video to the cloud and waiting for an alert.
That immediate feedback loop sounds powerful. And you mentioned scalability earlier. How does that work?
Right. With Edge AI, scaling often means deploying more edge devices. You don't necessarily need a massive upgrade to your central cloud infrastructure every time you add more intelligence points.
Because the processing is distributed.
Exactly. The power is spread across the network of devices. So expanding intelligence can often be as simple as adding more devices at the edge.
So a more distributed, maybe more cost-effective way to scale intelligence. Okay, we understand the why, the benefits. Let's get into the what. What are the key components that actually make up these edge AI systems?
Okay. An edge AI system is really a combination of several key pieces working together. The foundation, naturally, is the edge devices themselves.
The hardware.
Right. And as we said, it's a broad spectrum. You start with basic sensors gathering the raw data temperature, light, sound, images. Then you have microcontrollers and microprocessors capable of some basic computation on the device.
Okay.
For more complex AI work, you'll find more powerful CPUs and GPUs integrated.
Yeah.
And increasingly, we're seeing specialized chips, neural processing units, or NPUs. Yeah, they're specifically designed to accelerate AI tasks, especially running neural networks efficiently. And of course, the device could be a dedicated IoT gadget or a more complex embedded system built for a specific purpose.
All range of hardware options, depending on the need. Now, what about the actual AI part?
That comes from the AI models. These are the machine learning models, often neural networks and deep learning models trained to do specific things, like recognizing objects, detecting anomalies, predicting failures.
And these are usually trained in the cloud first, where there's more power.
Often, yes. They're developed and trained on large data sets, typically in the cloud where you have ample resources.
But then they need to run on these smaller, less powerful edge devices.
Exactly. So a crucial step is optimizing these models, making them smaller, faster, and less power hungry so they can actually run efficiently on that edge hardware. There are various techniques for this.
And how do these optimized models get onto the devices and actually run?
That's where software frameworks come in. They provide the tools and libraries needed to develop, train, deploy, and manage these models on the edge devices.
Like TensorFlow Lite, I've heard of that.
Exactly. TensorFlow Lite is a prime example, a streamlined version of TensorFlow for mobile and embedded devices. Another one is ONNX Runtime, which lets you run models from different training frameworks on various hardware. These frameworks handle the efficient inference step.
Inference being using the trained model to make predictions on new data.
Correct. Doing that efficiently on limited edge hardware is what these frameworks enable.
So frameworks bridge the gap between the AI software and the edge hardware. What's the final piece? How do they all connect?
Connectivity, that's the last crucial component. Edge AI systems need ways to exchange data.
Makes sense.
For short-range communication between nearby devices, you might use Wi-Fi or Bluetooth. For longer distances, maybe connecting back to a central system or the cloud for updates or sending summaries, you'll use things like cellular networks, including 5G or low-power wide-area networks.
OP1, like LoRaWAN.
Precisely. Technologies like LoRaWAN are great for devices that send small amounts of data over long distances using very little power. So getting all these pieces, the devices, the optimized models, the frameworks, the right connectivity working together seamlessly is key to a robust edge AI solution.
It really sounds like a carefully orchestrated system, hardware, software, networking, all playing their part. Okay, let's make this more concrete. Where are we seeing edge AI making a real difference? Manufacturing seems like a big one.
Manufacturing is definitely a major area, and one of the biggest impacts is in real-time anomaly detection.
Finding problems as they happen.
Or even before they happen. By using sensors to constantly monitor things like machine vibration, temperature, sound, electrical current, edge AI can spot tiny deviations from normal operation almost instantly.
Like a machine starting to vibrate slightly differently?
Exactly, something a human might miss or only catch later. Edge AI provides that continuous vigilance, shifting detection from periodic checks to right now.
That sounds incredibly valuable for catching issues early.
It is. It has huge implications for quality control and predictive maintenance. For quality control, imagine smart cameras using edge AI on the assembly line.
Inspecting products.
In real time. Spotting tiny defects, maybe subtle flaws in paintwork or assembly as the product moves along. This allows immediate rejection if needed. It acts like a tireless, super precise inspector.
Catching defects right away minimizes waste and improves overall quality.
Precisely. And for predictive maintenance, analyzing those same sensor readings vibration, temperature lets the AI learn a machine's normal heartbeat.
And detect when it's off.
Right. It can identify subtle patterns that indicate a potential failure is developing before the machine actually breaks down. This lets manufacturers schedule maintenance proactively.
So fixing things before they fail rather than reacting afterwards.
Exactly. It transforms maintenance from reactive repairs to planned interventions. That saves a massive amount of money lost to unplanned downtime, extends equipment life, and cuts unnecessary maintenance costs.
And doing that analysis right there on the factory floor means the alerts are immediate. No cloud delay.
Correct. Real-time alerts, real-time predictions, without relying on a potentially laggy cloud connection. That immediacy is key in manufacturing.
So spotting tiny flaws or predicting major breakdowns, that immediate intelligence allows for faster or better responses. What else is edge AI doing in factories?
Well, beyond just anomaly detection, it's improving quality control more broadly. Deploying advanced AI and deep learning on-edge devices connected to cameras and sensors lets you monitor quality constantly.
More detailed monitoring.
Much more. These systems can be trained to find minute dimensional errors, surface flaws, assembly mistakes with really high accuracy, often better than human inspection for certain tasks.
Okay.
And when a defect is detected, it can immediately flag it for rejection, like we said, or even trigger automated adjustments upstream in the process to prevent more defects. That real-time feedback loop is invaluable for cutting waste.
It's like having an incredibly vigilant QA inspector at every step.
That's a good way to put it. And finally, there's process optimization. Edge AI can analyze data from all over the production floor, sensors, environmental conditions, resource use to find inefficiencies.
And suggest improvements.
Or even make real-time adjustments. For example, analyzing machine speed versus energy use to recommend tweaks for better throughput with less power consumption.
Interesting.
Or monitoring assembly tasks to find bottlenecks and suggest workflow changes. This constant analysis and dynamic optimization right at the edge leads to big gains in productivity, lower operational costs, and better resource use.
So it's not just fixing problems, but actively making the whole operation smarter and more efficient. That's a profound impact.
Okay, let's switch gears to another vital sector, energy. How's edge AI being used there?
The energy sector is facing huge pressures. Efficiency, sustainability, reliability, and edge AI is becoming a key tool. Predictive maintenance is a big application here too, just like in manufacturing.
For things like wind turbines and power grids. Exactly. Think about remote wind turbines, huge solar farms, the complex power grid, massive transformers and substations. These are critical assets, often spread out geographically.
Right.
They're increasingly fitted with sensors collecting tons of operational and environmental data. Edge AI analyzes this data stream in real time to spot subtle signs of trouble,
That's just
like analyzing vibration patterns in a wind turbine to detect early wear before a major failure, or monitoring transformer temperatures to predict overheating risks, which can cause outages. Again, it's about shifting from reactive fixes to proactive intervention based on data.
identifying those early warnings to prevent bigger issues, just like in the factory.
Precisely. This lets energy companies optimize maintenance schedules, do repairs only when needed based on the AI's insights, cutting costs, minimizing downtime, and ultimately leading to a more reliable energy supply for all of us.
And more reliable energy has benefits across the whole economy. What else is Edge AI doing in energy?
Smart grid management is another crucial area. Modern grids are complex, with energy flowing in multiple directions, especially with more renewables coming online.
Right, it's not just one-way flow anymore.
Edge AI helps manage this complexity. By analyzing real-time data from smart meters, grid sensors, substation equipment, it helps balance energy supply and demand constantly. It acts like an intelligent control system for the grid.
Kind of like air traffic control for electricity.
That's a great analogy. It allows for dynamic adjustments in energy distribution, managing congestion, optimizing flow to reduce losses, improving overall grid stability and resilience.
So it can react quickly to changes.
Yes. For instance, during peak demand on a hot day, or if there's a sudden disruption, Edge AI can analyze consumption patterns and adjust outputs from different generation sources to prevent outages. That local processing and quick decision-making at the edge is essential for a responsive, efficient grid.
Moving towards a smarter, more adaptive power system, what about integrating renewables like solar and wind? They can be intermittent.
That intermittency is a challenge, definitely. Sunlight varies, wind fluctuates. Edge AI helps smooth this out.
How so?
By analyzing real-time weather data and historical generation patterns, Edge AI models right at the wind farm or solar plant can make much more accurate short-term forecasts of energy production.
Better predictions mean better planning.
Exactly. This helps manage energy storage systems, like large batteries, much more effectively. The AI can optimize charging and discharging based on predicted generation and demand, making the renewable supply more reliable for the grid.
Okay.
Plus, Edge AI helps maintain grid stability by enabling rapid adjustments to fluctuations in renewable supply, synchronizing it better with traditional power sources. That localized intelligence is key to maximizing clean energy use and building a sustainable ecosystem.
Making renewables more dependable and integrated. That's vital. Okay, let's turn to healthcare, a sector where this could have a very direct human impact. How is Edge AI changing patient care?
Healthcare is definitely a field where Edge AI promises transformative changes. Real-time patient monitoring is a huge area.
Wearable devices and sensors.
Exactly. We're seeing more and more devices that continuously track vital signs, heart rate, blood pressure, glucose, oxygen levels, even movement patterns. The key insight is Edge AI enables proactive, personalized care through this constant data stream.
Providing a constant flow of health data.
Right. And crucially, the Edge AI processing is increasingly built into these devices. The AI on the device analyzes the data locally,
Looking for problems.
looking for significant deviations from the patient's normal baseline or patterns that might indicate a developing health issue.
I have to find something.
It can generate immediate alerts to healthcare providers or even the patient directly. This allows for much quicker intervention and proactive management. It's incredibly valuable for remote monitoring, managing chronic conditions, or home recovery.
So earlier detection, faster response.
And it opens the door to truly personalized healthcare, where treatments can be adjusted based on real-time physiological data.
That sounds like a significant step forward. What other healthcare applications are emerging?
Diagnostic imaging is another exciting area. AI algorithms are being deployed directly onto imaging equipment, X-ray, MRI, CT scanners.
So the intelligence is in the scanner itself.
Yes. The Edge AI analyzes the images locally right after they're captured. It can help detect subtle abnormalities, identify tumors or fractures, assisting radiologists in making faster, more accurate diagnoses.
And processing locally avoids sending huge image files across the network.
That's a major benefit. It speeds up the whole diagnostic workflow, improves efficiency in hospitals, and potentially cuts costs related to data transmission and cloud storage. Faster diagnosis means quicker treatment, leading to better patient outcomes.
That faster turnaround could be life-changing in some cases. What about emergency situations?
Edge AI has huge potential in emergency care, too. Those first few minutes are often critical.
How can Edge AI help first responders?
By putting advanced diagnostic support right there at the scene. Wearable sensors or portable devices with Edge AI can collect and analyze a patient's vital signs in real time. The AI can offer immediate insights and recommendations to paramedics.
Helping with faster diagnoses and treatment decisions on the spot.
Exactly. Before even reaching the hospital, imagine a connected ambulance analyzing a patient's condition and sending key data ahead to the emergency room.
So the hospital is better prepared on arrival.
Much better prepared. That immediate information flow and on-the-spot intelligence can significantly improve care quality in emergencies and potentially save lives. It brings advanced diagnostics right to the point of care.
Bringing that intelligence to the front lines of emergency medicine sounds incredibly impactful. Okay, let's shift again to retail. How is Edge AI changing how we shop and how stores operate?
Retail is another sector being reshaped by Edge AI, especially around personalized customer experiences.
Making shopping more tailored.
Yes, using in-store devices like smart displays or kiosks equipped with Edge AI, retailers can analyze customer behavior in real time, what they look at, where they pause, maybe even link it to past purchases if the customer opts in.
Gaining a deeper understanding of the shopper while they're shopping.
Precisely. This local analysis allows for targeted product recommendations, personalized offers, relevant promotions delivered right there in the moment.
Can you give an example?
Sure. Imagine smart shelves detecting you picked up, say, a particular brand of pasta. A nearby screen could then instantly display a recipe using that pasta or show a special offer on a complimentary sauce. That immediate, relevant personalization enhances satisfaction and can boost sales and loyalty.
Like a super smart, subtle personal shopper. What else is happening in retail?
Autonomous checkout is a big one, heavily reliant on Edge AI, using machine vision and AI running on edge devices like cameras and sensors throughout the store.
That just walk out stores.
Exactly. Customers select items, walk out, and the Edge AI system tracks everything, identifies products, and processes the payment automatically. It's all about convenience and efficiency.
Eliminating checkout lines sounds appealing.
Definitely. And even in traditional or self-checkout lanes, Edge AI can improve efficiency and security. It can help detect suspicious behavior suggesting theft, or use computer vision to verify items being scanned, reducing errors and shrinkage.
Making checkout faster and more secure. What about managing inventory, knowing what's on the shelves?
Crucial for retail. Edge AI helps optimize this significantly. Smart shelves with weight sensors or RFID, plus AI-powered cameras, give real-time inventory visibility.
So no more guessing what's running low.
Right. The local AI processes this data, detects low stock or out-of-stock situations, predicts future needs based on trends, and can even automate reordering. This minimizes overstocking and ensures products are there when customers want them.
And loss prevention. Preventing theft.
Edge AI plays a role there too. Real-time video analysis can detect theft or suspicious activity, alerting staff immediately to intervene and reduce losses.
So from personalized recommendations to automated checkout and smarter inventory, Edge AI seems to be touching almost every part of retail operations. Okay, let's head to the fields of agriculture. How is Edge AI enabling precision farming?
Agriculture is undergoing a major tech shift, and Edge AI is central to precision farming. Farmers are using sensor networks across fields.
Collecting data on soil, weather.
Exactly. Real-time data on soil moisture, temperature, nutrients, local weather. Edge AI systems analyze this data right there in the field.
Providing immediate insights.
Actionable insights.
Yeah.
Helping optimize planting density, irrigation schedules, fertilizer application. It supports variable rate technology or VRT.
VRT.
Applying resources, water, fertilizer, pesticides, precisely where and when needed based on the sensor data and AI analysis. Not just broadcasting it everywhere.
So more targeted application.
Much more. Maximizing efficiency, reducing waste, minimizing environmental impact. It empowers data-driven decisions for better yields and more sustainable practices.
Shifting from broad strokes to precise data-driven farming. What about monitoring crop health over large areas?
That's historically been tough. Edge AI helps here using drones or UAVs equipped with high-res cameras and onboard processing.
Drones analyzing images as they fly.
Yes. Analyzing multispectral imagery in real time to assess crop health, spot early signs of disease, pests, or nutrient deficiencies often before they're visible to the naked eye.
Catching problems earlier.
Much earlier. The onboard edge AI generates detailed maps showing affected areas, allowing for targeted treatments like spraying pesticides only where needed. Minimizes crop loss and pesticide use.
More efficient and greener pest management. Does edge AI play a role with livestock too?
It does. Wearable devices for animals, smart collars or tags track vital signs like temperature and heart rate, plus movement and behavior patterns.
Like fitness trackers for cows.
Kind of, yeah. The edge AI analyzes this data locally on the tag or a nearby receiver, looking for abnormal patterns indicating illness, injury, or distress.
And alerts the farmer.
Exactly. Real-time alerts allow for timely intervention treatment, separation, improves animal welfare, reduces losses, and boosts overall farm efficiency.
Bringing precision and insight to every aspect of farming, from soil to crops to livestock. It's amazing how versatile this technology is.
Yeah.
But it can't all be smooth sailing. Implementing this must involve some serious challenges.
Oh, absolutely. While the potential is huge, there are significant technical hurdles and practical challenges.
Like what? What are the main constraints?
A big one is the hardware limitations on the edge devices themselves. Limited processing power, memory, storage compared to cloud servers.
So running complex AI models is tough.
It requires significant optimization. Techniques like model pruning, quantization, knowledge distillation, basically making the model smaller, faster, and less resource hungry without losing too much accuracy.
The balancing act.
Definitely. Then there's the environment. Many edge devices operate in harsh conditions, extreme temperatures, humidity, vibration. The hardware needs to be robust.
Built tough.
And power consumption is critical, especially for battery-powered devices like sensors or wearables. You need energy-efficient algorithms and hardware to make them last.
So technical constraints on hardware and power. What about managing these systems once they're deployed?
That brings operational challenges. Managing potentially thousands of geographically distributed AI-enabled devices is complex.
How so?
Ensuring consistent performance across different devices and environments. Handling software and model updates remotely and reliably. Continuously monitoring the health and security of this distributed network. It's a big task.
Keeping everything up to date and secure across potentially vast distances.
Right. You need rigorous testing, reliable over-the-air OTA update mechanisms, and scalable management tools for provisioning, configuration, monitoring, and maintenance.
A whole management layer is needed. What about fitting edge AI into existing systems? Integration challenges.
Yes, that's another major hurdle. Integrating edge AI with existing IT infrastructure or older industrial control systems that weren't designed for decentralized computing can be difficult.
Legacy systems causing headaches.
Often. And the lack of universal industry standards can create interoperability issues between different vendors' hardware and software.
Making it harder to piece things together.
Security is also a big concern in distributed environments. Devices out in the field can be more vulnerable to physical tampering or cyber threats than centralized systems. Robust security measures are essential.
Protecting the edge itself.
And finally, data management at the edge is tricky. How do you collect, store, process, and move data efficiently, given limited storage? How do you filter locally before potentially sending data onward? Data governance at the edge is complex.
So navigating technical limits, operational complexity, integration issues, security, data management, lots to overcome to realize the full potential.
Okay, shifting to the market view. What does the business landscape look like for edge AI in these industries? Is it growing?
Oh, it's growing significantly. Market reports show really substantial growth, and analysts project strong expansion for years to come.
Can you give us a sense of the scale? Sure. Figures vary slightly depending on the report scope, but we're seeing projections like the global edge AI software market potentially exceeding $45 billion by 2033, with growth rates around 36% annually.
Wow, that's fast growth.
It is. The broader market for AI, specifically tailored for vertical industries, could hit over $115 billion by 2034. And the hardware market, the chips, the devices, is also booming, maybe reaching $55 billion by 2029, growing around 18% annually. These numbers consistently show a dynamic, rapidly expanding market.
Impressive figures. What's driving this rapid expansion?
Several key trends are converging. First, the sheer explosion of IoT devices generating massive amounts of edge data that needs local processing.
More data, more need for edge analysis.
Exactly. Then there are the ongoing advancements in AI algorithms and more powerful yet energy-efficient edge hardware, The tech is getting better and more capable.
Makes sense.
The rollout of 5G and better networks provides the fast, reliable connectivity needed for many edge AI applications, especially those involving video or large data streams.
Better pipes for the data.
Plus, the increasing focus on data privacy and security makes local processing via edge AI more attractive than sending everything to the cloud.
Keeping sensitive data local.
And finally, just the growing adoption across all those key industries we've discussed: manufacturing, healthcare, retail, energy, automotive, agriculture. As adoption increases, the market grows.
So a combination of more data, better tech, improved networks, privacy concerns, and real-world adoption. Who are the main companies driving this?
It's a really diverse ecosystem. You have the major tech giants, NVIDIA, Intel, Google, Microsoft, IBM, AWS, all investing heavily, providing hardware, platforms, cloud services that support edge AI.
The big players are involved.
Definitely. Then you have established industrial automation leaders, Siemens, GE, Rockwell, ABB, Schneider Electric, integrating edge AI into their industrial solutions.
Bringing it to the factory floor.
Semiconductor companies are crucial too. Qualcomm, MediaTek, Samsung developing the specialized chips, the SoCs, optimized for edge AI workloads.
Powering the devices.
And there's a vibrant scene of specialized edge AI companies and startups, places like Edge Impulse, Foghorn Systems, Uptake Technologies, offering innovative platforms and tailored solutions. It's this mix of big companies and focused startups that's really pushing innovation and adoption forward.
A dynamic and competitive space. Now, for someone listening who might be interested in working in this field, what skills are really needed? It sounds like a unique mix.
It absolutely is. It requires a blend of expertise. First, a solid understanding of embedded systems is crucial.
Because it runs on resource-constrained hardware.
Exactly. You need to understand hardware architectures, how to optimize for devices, efficient programming for embedded platforms.
Embed knowledge.
Then, naturally, strong AI and machine learning skills are essential. Data management, model development, training, optimization, deployment, the whole life cycle, but with an eye towards edge constraints. Understanding algorithms, deep learning frameworks, model compression techniques is key.
Core AI skills, adapted for the edge.
Precisely. But what really makes it unique for these vertical industries is domain-specific knowledge.
Understanding the industry itself.
Critically important. You need to grasp the challenges, requirements, nuances of manufacturing or healthcare or energy or retail or agriculture. Knowing industrial automation for manufacturing or medical regulations for healthcare, that context is vital.
So tech skills plus deep industry understanding.
Absolutely. And skills in data engineering are valuable for managing data flow, and cybersecurity principles are increasingly important for protecting edge deployments. Ultimately, it often comes down to cross-disciplinary collaboration, getting embedded systems folks, AI experts, and industry specialists working together effectively.
It sounds like a challenging but rewarding field for those who can bridge those different areas of expertise. Well, we've certainly covered a lot of ground today.
We have indeed. From defining edge AI and its benefits, reducing latency, enhancing security to its core components, and then exploring its transformative applications across manufacturing, energy, healthcare, retail, and agriculture.
We also touched on the very real technical and implementation challenges that need navigating.
And looked at the significant market growth and the diverse range of players driving this field forward.
Underlining the importance of that specialized, interdisciplinary skill set required for success.
It really is a pivotal technology trend, bringing intelligence closer to where data is born, overcoming cloud limitations, and offering compelling advantages in speed, security, and reliability.
It's clear edge AI is reshaping industries and holds immense promise. So for you, our listener, here's a final thought to chew on. As intelligence continues to move to the edge, how will this fundamentally reshape not just these industries, but our everyday interactions with technology and the physical world?
What new possibilities, what potential disruptions might emerge as more and more devices around us gain the ability to perceive, learn, and act autonomously right there at the edge?
It's definitely a fascinating evolution to watch.